Hello everyone, welcome to the first lecture of Structural Analysis 1. So in this lecture, in the first unit basically, we will be learning about the analysis of indeterminate structures. Now, before we go to the analysis and procedures, let us understand what do you mean by an indeterminate structure. Now, an indeterminate structure is a structure which cannot be analyzed with the help of the equations of equilibrium only. It says that, or we can also say that we can only analyze those structures with some extra equations or extra modifications we need to do in order to analyze them. Write the name of the topic, that is analysis of indeterminate structures. Okay, so in this one, let's give the first heading sorry for that. Indeterminate structures. So the structures which cannot be analyzed with the equations of equilibrium only are called indeterminate structures. Okay, now this indeterminacy of structure can be classified into two major categories. First one is the static indeterminacy and the second one is kinematic indeterminacy. And again, the static indeterminacy can be further classified into internal indeterminacy and external indeterminacy. So let's jot it down. So this indeterminacy, as you can classify it as static, kinematic, and this static indeterminacy can be further classified as the external and internal indeterminacy. Now, let us say, what is this external indeterminacy? So this external indeterminacy is the indeterminacy in the structure which rises due to the external reactions, right? So let's give the first heading, or let's make a table. So in this one, external indeterminacy Now the type of structure, and the formula to be used. Okay, so let us say external indeterminacy is represented by E, and let us say the first type of structure is continuous beams. Next I have frames. Next type of structure is trusses. Okay, now for these type of structures, what is the formula we can directly use in order to determine the external indeterminacy? So the formula which we will use is E equals to capital R minus small r. So the same formula we will use to calculate the external indeterminacy of any structure, right? So now let us see what is E. E is the external indeterminacy, as I said. What is capital R? Capital R is the number of unknown forces. What is small r? Small r is the number of equilibrium equations. Okay, so my capital R is the number of unknown reaction forces, and my small r is the number of equilibrium equations. Now let's take some examples for this one. So we can write a question. So analyze the structures and state their external indeterminacy. Analyze the structures and state their external indeterminacy. So the first structure which I have is, let us take a simply supported beam. Next I have a cantilever beam, right? Next I have a continuous beam. I'm just drawing the skeletal structure. Next, let us say I have one more continuous beam with a roller at one support and a hinge at the other. Now let's take another one. Let us say we have a frame structure. So this is a frame structure. Next, let us take a truss. I am really sorry for the drawing because my hand is very unstable, and I hope you can please adjust with it and don't mind. So let's determine the external indeterminacy for these structures, right? So in the first example, So for this first example, we have a reaction, a vertical reaction will be here, a horizontal reaction will come, and another vertical reaction will come. So my R, that is number of unknown KNOWN unknown forces equals to 3. Now what is smaller? Smaller is the number of equilibrium equations. So what are the equilibrium equations? I have 3 equilibrium equations: summation fx equals to 0, summation fy equals to 0, and summation of all the moments will be equals to 0. So I have 3 number of equations, so that's why my r becomes 3. And remember, this small r will always, in most of the cases, it will be 3. Okay, so my r minus r equals to, that is external indeterminacy, equals to r minus r, that is equals to 3 minus 3, that becomes 0. So this simply supported beam is a determinate structure, as it doesn't have any external indeterminacy. Right? Now let's take the next example. So here, as this is a cantilever beam and it has got one fixed support, then due to that fixed support I will have a vertical reaction here, I will have a horizontal reaction here, and I will have a moment over here. So similarly, here E equals to, again, capital R minus small r. So my capital R is 3 minus small r is 3, that becomes 0. So I can say that this cantilever beam is also a determinate structure. Why? The external indeterminacy is 0. Right? Now let's come to the next structure, a continuous beam. In this continuous beam, so due to the fixed support, here there will be 2 reactions, plus 1, 3. Now here I will have one more vertical, one horizontal, one vertical, one horizontal, one vertical, one horizontal. So I can say my E, that is the degree of external indeterminacy, equals to R minus R. So number of capital R is the number of unknown forces. So 3 plus 2 plus 2 plus 2. So it is 6 plus 3 is 9 minus R, that is, or it is 9 minus 3, that becomes 6. So the degree of external indeterminacy is 6. So it means that we need another 6 equations in order to solve this one. Right? Or I can say that these 6 equations are extra. Or sorry, not equations, 6 forces are extra, which are to be determined, or which cannot be determined directly by using the equation of equilibrium. Now let's take the next example. So I have again 3 here, right? If I am not mistaken, this is 1, this is 1, this is 1. So 2 plus 1 3 plus 1 4 plus 2 6. So my E equals to 6 minus 3, that becomes 3. So similarly, let's take the frame. So I have 3, let us say it is like this. So my E equals to R minus R, that is 3, sorry, so it is 6 minus 3, that becomes 3. Okay, so this frame is indeterminate by a degree, or externally indeterminate by degree 3. Now let's take this one. So again 1, 2 and 3. So my E equals to R minus R, that is 3 minus 3 equals to 0. So this means that this truss is a indeterminate structure. So let us take some more examples. Let us say I have a frame like this, a 2-bay frame. So let us say this is fixed, this is hinged, and this one is also fixed. Next, I have a frame here where the bottom support is fixed. Let us say I have a truss here where it has got multiple number of supports, for example. This one. So let's solve one by one. Then we will go to the next concept. So first, so as I said, so it is fixed. So 3. This is 1. This is, let us say, another one. This is 1. This is 1. And this one. So my E equals to capital R minus small r, that is number of R or capital R, and that is the number of unknown reactions. 3 plus 2 5 plus 3 8 minus 3, that is equals to 5. So the degree of external indeterminacy for this structure is 5. Now let's see this one. So this is as simple as that of the cantilever beam. So E equals to R minus R, that is 3 minus 3, that is equals to 0. Now let's take the next example. So here I'll have 1 here, I'll have 1 here, I'll have 1 here, I'll have 1 here, also 1, I'll have 1 here. So E equals to R minus R. Number of unknowns 1, 2, 3, 3, 6. 6 minus 3, that is equals 3. This implies the degree of external indeterminacy for this structure is